What are you doing to that tree?
Painting it.
With what?
Just some potassium iodide and lead nitrate.
Oh, good. That's awesome. You're helping with the agriculture of the tree.
Wait, how does it help do that?
With the same chemical reactions that the stuff that paint was made of back in the day. I can show you how.
Well, I gotta go watch my gold. I know that farmer is coming to get me.
Okay, here. I'll make you a video, but it's gonna cost you some gold.
I wanna know, but I definitely don't wanna have to pay. I have an idea. Sure.
Okay, so now that we have our little experiment that our leprechaun gave us, we are going to go to our little lab. And this is us, as you can see. So, we are going to start with our chemical equation, which is going to be Ki plus PbNO3, parentheses 2. So now that we have our little double replacement, so it's a double replacement because we have 2 on each side. So we're going to predict the reaction. So because we have our anion and our cations, we are going to swap our cations, leaving our anions, so we can predict the reactions. Now it's going to give us KNO3, and it's going to give us PbI. Which, as you can tell, this is probably not balanced, because this 2 goes to this PB, which means now this PB2 is going to have to go down here, creating PbI2. Now, because this NO3 has this 2, we got to give this guy a 2. But now that we now have 2 Ks, we got to put a 2 back here. So now that we have 2 Is, 2 Ks, 2 NO3s, and then 1 PB, we now have our balanced equation, which, let's make this a little neater. Okay, so now that we have him a little bit out of the way, we're going to keep him up there. So, since this is our now balanced equation, we're going to separate these 2 guys, because even though they're like one kind of chemical equation, we're going to kind of make them into 2, because each of these kind of create a different reaction. So, first we're going to go over this guy. This is actually going to create this paint. And this paint was the paint that the leprechaun was using on the tree. However, lead iodide is toxic, which is why lead-based paint was discontinued. Lead poisoning can be very dangerous, especially for children who may have ingested the paint. So first you're going to use a dropper and you'll measure 20 milliliters of potassium iodide. So you're going to use the dropper to pour the 20 milliliters of potassium iodide into this graduated cylinder. Once you have the graduated cylinder, you're going to carefully pour it into the beaker, as you can see here, making sure to clean the dropper and the graduated cylinder thoroughly to avoid contamination to the solution. Now that you have that, you're going to set that aside and you're going to measure 21 milliliters of lead nitrate. And then, finally, you're going to pour the lead nitrate solution into the beaker containing the potassium iodide, and you're going to watch as the reaction takes place, and a yellow precipitation, lead iodide, forms. Be careful, this will stain, as you can see here, but it creates this really cool paint. So this yellow pigment has earned the nickname Golden Sunshine, as it's fascinating how the reaction visually illustrates concepts like solubility and crystallization. The formation of the lead iodide crystals results in the yellow paint, as you can see. So obviously we won't show an actual tree dying, as that would be kind of mean. Instead, use this kind of visual. So think of this as the yellow is the paint, which obviously, think about it as the leprechaun was painting on the tree, it was going down into the soil, which then created these little like tunnels kind of that isolated the pathogens. So like as if the orange was the pathogens. So that's how this entire chemical formula not only creates this paint, but also creates this little like protection of disease. So kind of fancy. So in conclusion, in this experiment we created lead iodide and potassium nitrate from a simple double replacement, our original. And the yellow pigment formed, showing how lead iodide crystallized, while potassium nitrate is so useful in the garden, helping trees and plants and other growing things protect themselves from parasites and diseases. And as for the leprechaun, well, I suppose we should tell him about our reaction. So you see how it works?
Wow, that's so cool. Can you send me that?
Sure. Done. It's sent. And here, I even made you some.
Love it.
Some paint for the road. Don't get in any trouble, though.
Me? Trouble? Never.
Now, okay. Now, where's my gold?
Darn leprechauns, why are they so fast? Stupid leprechauns and how fast they are. Why do they have to be so fast? They do everything in a pinch. The farmer is coming to get me looks around.
Because I'm just going to edit that anyway.
Okay.
Okay.
I'll let you cook.
Oh, wait.
Nothing happened. Wait. Where is it? Come back. Come back. I beg of you. Here we go. Oh, flip. Not too much. Wait, stop. There we go.
I feel like we're on the
So now that we have our... Hello?